Hello, today I will be going over some of the areas of statistics such as creating an experiment and finding information from data collected in a sample. My name is Joel Jeffries, and Ben Barrs and I worked together on researching and creating this video. During this video, I will discuss how to take a sample, how to organize data into charts or graphs, how to find measures of central tendency from data, as well as finding measures of dispersion, building confidence intervals, and how to set up hypothesis testing. So for our experiment, my partner and I went online and found some information about the amount a college-age student texts. Nielsen released in the fall of 2010 that an 18 to 24-year-old sends about 1,630 texts a month. For the sake of our experiment, that means that the same age group sent an average of 54 text messages per day. So this brings us to our experiment. The most important thing you need for an experiment like this is the question defining the experiment. In our case, the question was, how many texts does a college-age student send per day? So now that we had our question, we were able to start creating a sample. For our experiment, we created an online survey as well as took a survey from our class. We got about 150 answers, and for the sake of this video, we randomly chose 100 answers to create our sample. When we first got our answers from the sample, which is called data, it was in raw form. As with any experiment, this is how you will record and receive the data, unorganized. Here's our data. It is the 100 randomly selected answers from our sample. As you can see, it is all random, and as such, it makes it hard to interpret or work with. So to make the data easier to look at, we first need to organize it. So here we are simply reorganizing the entire set of data in increasing order. This helps us be able to work with the data more efficiently. Now to organize the data even more, we can put it into charts or graphs. For our data, we will go over the process of putting the data into a frequency distribution and then graphing it on a bar graph. So here we have half of our frequency distribution chart. As you can see, the chart has two columns, one labeled class and the other labeled frequency. We have already set the classes for our distribution. You can see that each has the same size, 29 texts per day. So next, we must find out how much of the sample falls within each class, or the class frequency. Here is our data. To find the frequencies of the classes, we must break the data into those classes and then count how many are in each. So here, you can see the numbers in red are the data points in the first class, 0 to 29. There are 50 of them, so the frequency of that class is 50. Next, we see the data points in the class 30 to 59. There are 21 of these, so that frequency is 21. Next, we see the class 60 to 89 with the frequency of 10. We can continue this until we have exhausted all the data points in classes. Here is the complete frequency distribution chart. You can see that the numbers corresponding in the frequencies on the last slide are in their respective classes. You will also notice that there are some zeros in the frequency column. This is because there were no data points found in those ranges in our sample. Now that we have our data arranged in a frequency distribution, it would be nice if we could represent it graphically to have a better look at it. A histogram is a nice way to visualize this sort of data. A histogram, also known as a bar graph, is a graph that displays the data on vertical bars of various heights representing the frequency of the classes of the data. Having a frequency distribution makes this extremely easy. As you can see on the bottom, each bar represents one of our classes we created. Then, the height of the bar determines the frequency of that class, as shown on the right. Now that we have our data arranged and have a way to visualize it, next we can start analyzing it. One way of analyzing data is by finding the measures of central tendency. A measure of central tendency is a single value that best represents the entire set of data. The four main types of measures of central tendency, and the ones that I will discuss, are mean, median, mode, and mid-range. These are the definitions of those four measures. The mean, or arithmetic mean, is the sum of the values divided by the total number of values. The median is the midpoint of the data. The mode is the most frequent data point, and the midrange, as it sounds, is the middle of the range of the data. The first measure of central tendency we will discuss is the mean. As you will see several times in the video, and in all of statistics, calculations made from a sample are sometimes dealt with slightly differently than calculations made on a population. This is because a sample is a less accurate representation of the population. Here are the equations for the mean for a sample and a population. The top equation states that the sample mean, or x bar, is equal to the summation of all the data points, represented by x, and then divided by the total number of data points, represented by the lowercase n. The population equation is identical, except the population mean is represented by a mu, that u-looking thing, instead of an x bar, and the total number of the population is represented by an uppercase N. For this video, we are working with a sample, so we will be using the sample equations. So to make this easier, we will take the equations step by step. The first step is to add up all the points. When we added up all the points of our set of data, we got 5,564. Next, we take that summation and we divide it by the size of the sample, which in our case is 100. Thus, we got our mean to be 55.64. This is a good representation of the average texts per day our sample had across all the participants. The next measurement of central tendency we will discuss is the median. The median is the middle number of the data. So for this, the data must be organized from least to greatest, which we have already done. Next, we must find the middle number of the data. The easiest way to do this is to cross off the same number of points from each side until you are left in the middle. In our case, we have two numbers in the middle. When this happens, you must find the number between these two numbers, or the mean of the two numbers, by adding the two and then dividing by 2. So by this, we got our mean to be 27.5. Next is the mode. The mode is the most frequent data point. By this I mean that it is the number that shows up most in the data. So for our data, the mode is 20, because there are more 20s on this chart than any other number. The last measure of central tendency we will discuss is the mid-range. You can think of the mid-range as the midpoint between the greatest and least values of the data. So to find the mid-range, you must find the greatest and lowest values. For our sample, this is 0 and 600. Next, you must add these two numbers together and then divide by 2. So for our sample, we got the mid-range to be 300. The four measures of central tendency represent the data in a single value, but in different ways. Some can represent the data fairly well, while others not so well. The mean is probably the most common measure of central tendency because it represents the average of a set and is less thrown off by extreme values, such as the 600 in our data, which can throw off the accuracy of some of the other measures, such as the mid-range. So here's the summary of the measures of central tendency that we just found. We found our mean to be 55.64 texts sent per month, the median to be 27.5 texts per month, the mode to be 20 texts per month, and the mid-range to be 300 texts per month. Another way that we can analyze our data is by finding the measures of dispersion. A measure of dispersion shows how spread the data is. 4 common types of measures of dispersions are the range, variance, standard deviation, and the mean absolute deviation. The range is the difference between the highest and lowest values. The variance is the average of the squares of the distance each value is from the mean. The standard deviation is just the square root of the variance, And the mean absolute deviation is the average of the distances of a value from the mean. So first, let's take a look at the range. To find the range, we simply need to find the highest and lowest values. Once we have those, we find the difference between them. In our case, we have a range of 600. Now let's take a look at the mean absolute deviation. The equation for the mean absolute deviation is this. It is the sum of the distances between the data points and the mean divided by the total sample size. Another way to look at this is that it is the averages of the distances from the data points to the mean. To help us work through this equation, we can break it down into a chart like this. You can see the difference between each data point and the mean in the third column, and then by taking the absolute value of these values in the fourth column, then the values represent the distance of each point from the mean. Next, you must find the average or the mean of these values. As you remember from what we discussed about mean earlier, you must add up all the values and then divide by the total number in the set. So for our data, we got the mean absolute deviation to be 48.07. So on average, the data varies about 48 texts per day from the mean. However, the mean absolute deviation is not very common in statistics. Instead, variance and standard deviation is used more often. Here we see the two equations for variance, one for sample and one for population. For the sample, s squared represents the variance. The equation for variance is all the differences between the data points x and the mean x bar is squared and then added together, and then finally divided by 1 less than the sample size n. The equation for population variance, labeled sigma squared, is similar, but is divided by the total size of the population. The sample is divided by 1 less than its size because the sample is less accurate and is thus more likely to vary greater from the mean. Once again, an organized way of working through these kind of equations is breaking it down into a chart. You will see in this chart that it is very similar to the one that we used for mean absolute deviation, only that the last column is squared instead of having an absolute value. This, like the absolute value, makes the values positive, but also artificially inflates the greater values. Then, like we did before, we're going to want to add up these values, and then finally divide it by, in our case, the total sample size minus 1, since this is representing a sample. So for our variance, we got 6,457.26. From the variance, we can find the standard deviation. Since we squared all of our values to find the variance, the standard deviation is simply the square root of the variance. So for our data, we got a standard deviation of 80.36. So for our measures of dispersion, we have a range of 600, a variance of 6,457, a standard deviation of 80.36, and a mean absolute deviation of 48.07. All of these values measure the spread of the data in very different ways.